Right, in this video we are going to discuss paper 1-2 of your O-level AddMath. It's May-June 2021, so let's start. Alright, in the first part, question we need to write PQR in this form. So we are going to apply the rules of indices here. In the numerator, it's PQR with the power -2 and R with the power 1 upon 3. So firstly, I will apply the power -2 on both of these three terms. So P power -2, Q power -2 and R power -2 times R power 1 upon 3 divided by P power -2, R power -1 and Q power Q. Alright, now we need to solve it. This P with the power -2, when you shift it in the numerator, so that will be P power -2, and this -2 when you shift in the numerator, it will be +2. Similarly for Q in the numerator, it's -2, and when you shift Q power 3 from the denominator in the numerator, so that will be -3. R in the numerator is -2 and 1 upon 3 already present, right? And this -3 when you shift in the numerator, it will be +1. Now we need to solve the powers here. So P is -2 plus 2, it's 0. Q is -2 minus 3, it's -5. And for R, we need to take LCM here, so that will be -2 plus 1, it's -1. So we can say that -1 plus 1 upon 3. We can take LCM of 1 upon 3 minus 1. So that is 3. 1 minus 3. It leads to -2 upon 3. So we can write in this form P power 0, Q power -5 and R power -2 over 3. If you compare it with the given question form, it's P power A, Q power B and R power C. So you can find out the value of A equals to 0, B equals to -5 and C equals to -2 upon 3, and that is your answer. Question number 2, we need to plot the graph of y equals to modulus of 4 minus 3x. Alright. First we talk about the intercept. So when we are talking about y-intercept, means the value of x is 0. Alright. So when you place x 0 in this equation, so that will be 4 minus 0 leads to the point, this one, right? So the coordinates for this point is 0, 4. Alright, now if you talk about the vertex point here, so at which point this whole modulus sign will be 0. So that is a rough work I'm going to do here. Alright, we have 4 minus 3x and we need to find out the value which make this expression equals to 0. So it's 4 equals to 3x, and we can say that x is equals to 4 divided by 3. It means when the value of x is 4 upon 3, the value of y will be 0, and that is my second and most important point, which is vertex point. So vertex is 4 divided by 3. Alright, that means the behavior of the curve will be like this. It will touch to this point and then bounce back. Alright, so the curve of this equation, the function is like this. It will meet this point and then bounce back. That is the curve of y equals to modulus of 4 minus 3x. Alright, for part B, we need to solve this equation. So we have 4 minus 3x with the modulus sign should be greater than equals to 7. To remove modulus sign, we need to apply squaring on both sides. So what we have, it's 4 minus 3x square should be greater than equals to 7 square is 49. Now there is an identity here. It's 16 minus 2 3s are 6 4s are 24x plus 9x square should be greater than equals to 49. We can solve it. 9x square minus 24x plus 16 minus 49 should be greater than equals to 0. After that we have 9x square minus 24x minus 23 greater than equals to 0. We can divide the equation by 3, or you can say we can take common here. So that will be 3x square minus 3 8s are 24x minus 11 greater than equals to 0. Now we can apply middle term method here. So that will be equals to 3x square minus 11x plus 3x minus 11 greater than equals to 0. It's x 3x minus 11 plus 1 3x minus 11 greater than equals to 0. Now we can take common 3x minus 11, and the leftover part we have, it's x plus 1 greater than equals to 0. Basically we are getting two values of x. The first one is -1 and the next one is 11/3, right? So if we sketch the curve roughly, so we are getting two values of x. The first one we are getting is -1 and the next one we are getting it's 11/3, right? So we are having a happy face curve because the x square coefficient is positive. So that's how my curve looks like, right? Now we need to find out the values for x. So for this range, since the graph is of greater than equals to 0, that means the region that we are looking for is this region, right, outside the curve, because it says greater than equals to 0. All right, so for this range of values we have x should be lesser than equals to -1 and the value of x should be greater than equals to 11 divided by 3, and these two set of values are your final answer. Question number 3 from the topic vectors. It says the diagram shows the quadrilateral OABC such that OA is A, OB is B and OC is C. The lines OB and AC intersect at the point P such that AP ratio PC is 3:2. Find OP in terms of A and C. Before finding the vector OP, I need to find out the vector AC first, alright? And for AC, I am going to write down the expression here that OA plus AC equals to OC. I can make AC the subject here, so AC leads to OC minus OA. The vectors of OC and OA are known. OC is C and OA is A, so that is a vector AC. Now why did I find the vector AC? Because I'm going to use this ratio here, right? So if it's AP ratio PC, we have the ratio 3:2, right? If I need to highlight this ratio on my figure, so AP is 3 and PC is 2, that means this total ratio we have it's 5, right? So I can say that if the ratio is 5, the vector is AC. What we are looking for is OP. For OP I need to find AP here. So if the ratio of AP is 3, what should be the vector of AP, right? Now we have the value of AC here, so I'm going to place the value in this equation. So if 5, the vector AC we have it C minus A. If the ratio is 3, what should be the vectors of AP? After doing cross multiplication, it's 5 times AP equals to 3 times C minus A. I can say that AP equals to 3/5 C minus A. Alright, once I have the vector of AP, I can write down the expression in this form: OA plus AP equals to OP. Alright, the vector OA is A, the vector AP is 3/5C minus 3/5A equals to OP. I can solve the vector A and 3 minus 3/5A together, so that will be A 5A. After taking LCM, it will be 5A minus 3A leads to 2A upon 5 plus 3/5C equals to OP, and that is your answer. In the next part, it says given also that OP ratio PB is 2:3, so that 2B equals to 3C plus 2A. Alright, first I'm going to write down the equation here. I'm going to say that OP plus PB and it is equals to OB. Alright, now what is OP? We have find OP in the previous part. OP is equals to 2A/5 plus 3/5C. Alright, plus what is the vector PB? We can identify the vector PB because the ratio we have known is 3. Alright, so that will be 3/5 of the vector B. B is basically the vector OB is equals to OB, it's B. Now we have an equation we need to simplify. Firstly, I will shift 3/5B on the right side, so that will be 2A plus 3C divided by 5 equals to B minus 3 divided by 5B. Taking LCM, so that will be 5B minus 3B, it's 2B/5 leads to 2A plus 3C/5. 5 and 5 cancel, so the leftover part we have it's 2A plus 3C equals to 2B, and we need to show the same expression. That is your answer. It's question number 4. The question says a curve is such that d square y over dx square equals to 3x plus 2 with the power -1/3. The curve has gradient 4 at the point 2 comma 6.2. Now it means that we have the value of dy over dx at x equals to 2 and the value is equals to 4. Find the equation of the curve. Alright, so we have the derivative equation d square y over dx square equals to 3x plus 2 with the power negative 1 upon 3. Alright, now we need to integrate that function. So before integration, the derivative of this function should be present with itself, right? So we need to multiply and divide it by 3. Now the derivative part of this function is present with it, right? So now the function is ready to integrate. I'm going to apply the sign of integration here. So the integral will be dy over dx is equals to 3x plus 2 with the power minus 1 upon 3 plus 1 divided by the power minus 1 upon 3 plus 1, and this 3 is present here, right? This 3, this one, and now we need to add positive c here. So when you solve 1 minus 1 upon 3, you will get 3 minus 1 divided by 3 and it is equals to 2 upon 3. So now we have 3x plus 2 power 2 upon 3 divided by 2 upon 3 times 3. We can simplify here. So the leftover part we have, it's 3x plus 2 with the power 2 over 3 divided by 2 plus c equals to dy over dx, right? Now the value of dy over dx is given in the question. When dy by dx equals to 4, the value of x is 2. So I am going to place all the values here. It's 2 upon 3 divided by 2 plus c. So it will be 3 2s are 6, 6 plus 2 8, right? And I can write 8 in the form of 2 power cube whole power 2 over 3 divided by 2 plus c. 3 and 3 cancel, so leftover part is 2 square is 4 divided by 2 plus c equals to 4. 2 1s are 2, 2 2s are 4, 4 minus 2 equals to c. That is your value, right? Now the curve equation, it will be, when you place the equation here, so that will be equals to dy over dx equals to 3x plus 2 with the power 2 over 3 divided by 2 plus 2. Alright, after that we need to find the equation of the curve. So again we need to integrate this function and again we need to multiply divided by 3 here because the derivative part should be present with it. Now the function is ready to integrate, right? So the integration will be y is equals to, so 2 over 3 plus 1 equals to 5 over 3. Alright, so now the integrated part would be 3x plus 2 with the power 5 over 3 divided by 5 over 3, and we have this 3 and 2, it will be 6, right? 2 times 3, it will be 6 here, right? And then we have plus 2 and the constant is d this time. It won't be 2, it will be 2x, right? Because it is integrated now. Now after that we can simplify, so 3 1s are 3 and 3 2s are 6. So we have the expression left over, it's 3x plus 2 with the power of 5 over 3 divided by 2, 5s are 10 plus 2x plus d and equals to y. Now we need to find out the value of d here. For that part we have a coordinate, it's 2 comma 6.2. So we have the value of x and we have the value of y. So I'm going to place the values here. So y is 6.2 equals to 3 times 2 is 6 plus 2 8 with the power of 5 over 3 divided by 10 plus 2 2s are 4 plus d. You can simplify the whole equation with the help of calculator. The value of d we will get is d equals to negative 1. Alright, now we are going to place the value of d in our final equation, this one. So now it will be y is equals to 3x plus 2 divided by 10 with the power of 5 over 3 plus 2x minus 1, and that is your final answer. Number 5 from the topic logs, it says log a of p plus log a of 5 minus log a of 4 equals to log a of 20. Find the value of p. The good thing about this question is that we have same basis, right? So it's easy to solve it now. So it will be log a of, so when we have addition, that means we need to multiply. and when we have subtraction, that means we need to divide, equals to log a of 20. On both sides of the equation we have log a and log a, that simplifies, so the leftover part is 5p equals to 4 into 20. So you can simplify, 5 ones are 5, 5 fours are 20. So the leftover part for p is equals to 16, and that is your answer. For part 2 it says solve the equation 3 to the power 2x plus 1 plus 8 into 3 power x minus 3. Alright. Firstly, if I break the power here, so that will be 3 to the power 2x times 3 plus 8 into 3 power x minus 3 equals to 0. Here we are going to make a substitution, and we are going to say that 3 power x equals to y. So this will be 3 power 2x, it will be y square, plus 8 3 power x, it will be y, and minus 3 equals to 0. So now you can apply the middle term here. So that will be 3y square plus 9y minus 3 equals to 0. You can take common 3y here. The leftover part we have is y plus 3 minus 1y plus 3 equals to 0. You can take common y plus 3 here, and the leftover part is 3y minus 1 equals to 0. So now you have two values of y equals to negative 3 and y equals to 1 upon 3. Right? The substitution we make was 3 power x equals to y. So when the value of y is negative 3, so it will be 3 power x equals to minus 3. If you take log here, so that will be log 3 power x equals to log of minus 3, which is not possible. And when we have y equals to 1 divided by 3, so it's 3 power x equals to y is 1 upon 3. You can say that 3 power x equals to 3 power minus 1. Both sides we have same basis, so x equals to minus 1, and that is your answer. For part C, it says 4 log y of 2 plus log 2 of y equals to 4, right? The first step, we have different bases. Here we have y and here we have 2. So now I'm going to apply the change of base law. So it will be 4 log y of 2 plus it will be 1 upon log y of 2 equals to 4. To make question easy, what I will do, I will make the supposition that log y of 2 equals to x. So now my question will be 4x plus 1 upon x equals to 4. If you take LCM, that will be x, so it will be 4x square plus 1 equals to 4, and if you simplify the equation, it will be 4x square minus 4x plus 1 equals to 0. Now you can solve it by middle term, so it will be 4x square minus 2x minus 2x plus 1 equals to 0. You can take common 2x here, so the leftover part is 2x minus 1. Here is minus 1, and leftover part is 2x minus 1 equals to 0. Again you can take common, that is 2x minus 1, and the leftover part is 2x minus 1 equals to 0. So you got the value of x, and it's equals to 1 upon 2, right? The supposition we have made, it's log y of 2 equals to x. The value of x we know it now, so it will be log y of 2 equals to 1 divided by 2. If we change the log form into index form, so that will be y equals to y to the power 1 upon 2. To cancel the effect of 1 upon 2, we need to apply a square on both sides. Alright, so it will be 4 equals to y, and that is your answer. Question number 6, and the question says do not use a calculator in this question. A curve has the equation y equals to 3 plus root 5x square minus 8 root 5x plus 60. Find x coordinate of the stationary point on the curve. Gives your answer in the form of a plus b root 5, where a and b are integers. Alright, to make question easy, what I will do, I will start with the differentiation, because it talks about the stationary point, right? And we know the given condition for a stationary point, it says dy by dx should be equals to 0. Alright, so we have the equation y, which is equals to 3 plus under root 5 x square minus 8 under root 5 x plus 60. If you start with the differentiation, so dy over dx equals to 3 plus under root 5 the derivative of x square, it will be 2x, right? Minus 8 under root 5, derivative of x is 1 and derivative of constant is 0. Now dy by dx is basically equals to 0 equals to 3 plus under root 5 times 2x minus 8 under root 5. We can shift 8 root 5 on the left side, it will be 8 under root 5 equals to 3 plus under root 5 into 2x, right? We need to find out the value of x here, so it will be 8 under root 5 divided by 2 times 3 plus under root 5 equals to x. Alright, so if I simplify it further, so that will be 2 1s are 2 and 2 4s are 8, so that will be 4 under root 5 divided by 3 plus under root 5 equals to x. We need to apply rationalizing here, so that means we need to multiply 3 minus under root 5 and divide it by 3 minus under root 5 here, right? Now we need to start with the multiplication. So 4 3s are 12, it will be 12 under root 5 minus 4 into 4 5s are 20, because the reason is why root 5 into root 5 equals to 5. So 4 5s are 20, and in the denominator we have an identity of a square minus b square. So a is 3 and b is under root 5. So in the numerator you can take common, that is 4, right? And the leftover part is 3 under root 5 minus 4 5s are 20. In the denominator it's 3 square is 9 minus 5, alright, and it equals to x. So 9 minus 5 is basically 4, right? I'm just writing right here. 9 minus 5 is 4 and 4 cancels. So the leftover part for x is 3 under root 5 minus 5 equals to x. You need to show your answer in terms of a plus b root 5. So if I arrange the equation in the same format, minus 5 plus 3 under root 5 equals to x, and the given equation in the form of a plus b under root 5. So you can highlight the value of a and b. A is negative 5 and b is positive 3. That is your answer. In the next part we need to find out the y coordinate of this stationary point. Give your answer in the form of c root 5, where c is an integer. So we need to place the value of x which we had found in the previous part in this equation of curve which was given in the question. So now it will be y is equals to 3 plus under root 5 x squared. The value of x is what? It's 3 under root 5 minus 5 square minus 8 under root 5. Again we have x here, that is 3 under root 5 minus 5, and we have plus 60. We need to simplify the equation. So firstly I will start solving with the identity part, this one, right? So I'm going to solve it separately. So it's 3 root 5 minus 5 with the whole square. The identity we have, it's a square minus 2ab plus b square. The value for a is 3 under root 5 and the value for b is 5, right? So 3 square is 9 5s are 45 minus 2 3s are 6 5s are 30 under root 5 plus 5 square is 25. I'm going to place the value for 3 root 5 minus 5 square. Instead of this I will place this value in this equation. So now the equation will be y is equals to 3 plus under root 5 times 45 minus 30 under root 5 plus 25 minus 8 under root 5 times 3 under root 5 minus 5 plus 60. Alright, after that we can add these two numbers 45 and 25, that will sum up to 70. So instead of 45 and 25 separately, I'm going to write down the sum of these two, it's 70, right? And now we are going to start with the multiplication. So 3 into 70, it's 210 plus minus minus. 3 3s are 90 under root 5 plus 70 under root 5 and plus minus minus 30 into 5, that leads to 150. Alright, minus 8 3s are 24 and 24 under root 5 it will be 5, minus minus plus 5 8s are 40 under root 5 plus 60. Now we have two type of terms, one which contain root 5 and the one which do not have root 5, right? So we are going to write them separately. It's 210 minus 150. 24 into 5 leads to 120 with the negative sign, and we have plus 60, right? And the term with root 5 we have plus 70 root 5 plus 40 root 5 minus 90 root 5. So now we can simplify 210 minus 150 minus 120 and plus 60. When you add all those numbers, they will cancel each other, so that will be 0. Plus 75 plus 40, 70 plus 40 leads to 110. 110 minus 90, that is 20 root 5. So the value for y coordinate is 20 under root 5, which is in the same form. We need to highlight it's c under root 5. The value for c we have it's 20, and that is your answer. Question number 7 from the topic permutation. It says a 6-character password is to be made from the following 8 characters. So you have 3 plus 2, 5 plus 3, 8 characters. No character may be used more than once in a password. Find the number of different passwords that can be chosen if there are no restrictions. So you have 8 total options, and among those 8 you need to select any 6. So it's 8p6, which is equals to 20160. That is your answer for the next one. The password starts with a digit and finishes with a digit. Alright, so we need to pick any 4 digits, 6 digits, 1 2 3 4 5 6, right? The condition says the password starts with a digit. So how many digits we have? We have 5 options, right? So we can say that for the first one we have 5 options for the first one, we have 4 options for the last one, right? The total we have it's 8 characters, right? Among those 8 characters, 2 occupied, so how many are left over? So that means the leftover characters we have is 6, and among those 6 characters we need to select any 4. So the option will be 5 into 6p4 into 4, which gives you the value of 7200. That is your second part answer. In the next part it says the password start with 3 symbols. Alright, so we have 6 characters, 1 2 3 4 5 6. The password starts with 3 symbols. That means the first 3 places have been occupied by the symbols. The remaining 3 places, right? These 3 places. Out of 8 characters, the 3 digits have been occupied, right? So the leftover part we have it's 5, and among those 5 we need to pick any 3. Alright, now for this one we need to select 3 characters, right? So it will be 3 permutation 3. So you can say that it's 3p3 times 5p3, which is equals to 360. Alright, for the last one, the number of combinations of 5 objects selected from n object is 6 times the number of combination of 4 objects selected from n minus 1 objects. Find the value of n. Alright, so we can say that the number of combinations of 5 objects selected from n objects, it's n c5 is 6 times number of combination of 4 objects selected from n minus 1. n minus 1 combination 4. We can expand the working formula here, so that will be n factorial divided by n minus 5 factorial times 5 factorial equals to 6 times. Here we are going to apply the same. It will be n minus 1 factorial divided by n minus 1 minus 4 factorial into 4 factorial. Alright, we have applied the working formula here. We need to simplify it. So n factorial can be written down as n into n minus 1 factorial divided by n minus 5 factorial into 5 factorial equals to 6 times n minus 1 factorial divided by n minus 1 minus 4 leads to n minus 5 factorial into 4 factorial. Now the equation we can simplify here, and we can do what? N minus 1 and n minus 1 cancels, n minus 5 factorial, n minus 5 factorial cancels. So the leftover part we have it's n divided by 5 factorial equals to 6 into 1 divided by 4 factorial. So after simplification you will get the value of n, and that is equals to 30. That is your answer. Question number 9 from the topic series, it says the first three terms of an arithmetic progression are minus 4, 8 and 20. So it's minus 4, 8 and 20. Find the smallest number of terms for which the sum of this arithmetic progression is greater than 2000. Alright. So first thing, we can find out the difference. Difference is what? Second minus first, so that will be 8 minus 4, that leads to 12. Alright, we have the value of a, which is the first term, it's negative 4. Now we have the difference as well. Find the smallest number of terms for which the sum. Alright, the key word here is sum. We need to apply the working formula for sum. Sum of n terms is n upon 2, 2a plus n minus 1 d. That is the working formula. We need to find out the value of n here, so it will be n divided by 2. A is minus 4, so it's minus 8 plus n minus 1, and d is 12. We can simplify it, so it's n upon 2 minus 8 plus 12n minus 12, or we can say that n divided by 2 and 12n minus 20. We can simplify it, n upon 2. Here you can take common 2 here, so when you take common 2 inside the bracket, it's 6n minus 10, right, and 2 and 2 cancel, so it's n into 6n minus 10. Now in the question, the keyword we have is greater than 2000, so now we need to include the sign of greater than here, and the term is 2000. Alright, so if you multiply the brackets here, so it's 6n square minus 10n, and if I shift 2000 on the left side, it's minus 2000 should be greater than 0. Alright, we can divide the whole equation by 2, so it's 3n square minus 5n minus 1000 divided is greater than 0. So you can apply a quadratic formula here, and after that you will get the values. N should be greater than 19.1 and n should be greater than minus 17.4. We are going to reject this one because it's negative, and n should be greater than 19.1 means that the smallest value of n should be equals to 20, and that is your answer. Alright, in part B it says that the 7th and 9th term of a geometric progression are 27 and 243. So we had given the 7th term, that is 27. We have the 9th term, that is 243. Given that the geometric progression has a positive common ratio, find this common ratio. By 7th term, it means that it's ar to the power 6 equals to 27, and by 9th term is ar power 8 equals to 243. First we need to find out the value of r, so what I will do, I will divide these two equations, so that will be ar8 divided by ar6 equals to 243 divided by 27. A and a cancel, so left over is r square equals to 243 divided by 27. It's 9, applying root on both sides, so you will get r value is positive 3, because it says in the question that r is a positive common ratio. For second part, it says find out the 30th term, giving your answer as the power of 3. So we need to find out 30th term. The working formula, it will be ar to the power 29. Alright, first we need to find out the value of a here. So as we had find in the previous part the value of r, so we had given in the previous part that ar to the power 6 equals to 27. Alright, now we have the power, we have the value for r, and that is equals to 3 to the power 6 equals to 27 is 3 to the power 3. So you got the value of a, that will be 3 to the power minus 3. You can say that it's 1 divided by 27, that is your a value. Now the term T30 we have is, what is a? A is 1 divided by 27 means 3 to the power 3. R is what? R is 3 to the power 29. You can solve it, it will be 3 to the power 26, and that is your answer. For part C, it says that explain why the geometric progression 1 sin theta, sin square theta, and so on for minus pi by 2 till pi over 2, where theta is in radians, has a sum to infinity. At first I need to find out the value of r here, so that will be equals to sin theta divided by 1, which is equals to sin theta. So we have the value of r here. Alright, Now the working formula for sum to infinity, you know that it is equals to a divided by 1 minus r, but that formula is valid only for the value of r should be lesser than 1. Alright, the modulus value of r should be less than 1. This condition satisfies this working formula for sum to infinity. The value for r we have its sine theta as I have shown above. So that statement will be sine theta should be lesser than 1. Alright. Now, you know that when we remove the sign of modulus, so that will be a positive 1 and a negative 1. So I can say that sine theta values lies between minus 1 and positive 1. Alright. As given the range in your question, minus pi by 2 means it's minus 90 degrees and pi by 2 means it's 90 degrees. So when you find out the value for sine inverse to find out theta, so you will get 90 degree for the positive side and you will get minus 90 degree for the positive side. Alright, so we can say that it is equals to 90 is basically equals to pi over 2 and minus 90 is minus pi over 2. That is the proof for your question, and the important statement in this question is this one, and the value of r we have find out with the GP. So that is your answer. June 21 paper 1-2 question number 10. Solve the equations sine alpha cosec square alpha plus cos alpha sec square alpha equals to 0 for minus pi till alpha till pi where alpha is in radian. Alright, so first thing we are going to apply the identity of cosec square. So it's sine alpha and cosec square is basically 1 upon sine square alpha plus cos alpha, and sec square is 1 upon cos square alpha equals to 0. You can simplify here, so sine alpha and sine power 2 cancel, cos alpha and its power 2 cancel. So the leftover part we have it's 1 upon sine alpha plus 1 upon cos alpha is equals to 0. If we take LCM here, so that will be cos alpha plus sine alpha divided by sine alpha cos alpha equals to 0. You can shift the denominator to the right side, so when it multiplies with 0 leads to 0. So we have sine alpha plus cos alpha equals to 0. When I shift cos on the right side, so it will be sine alpha equals to minus cos alpha, and I can say that it's sine alpha divided by cos alpha equals to negative 1. Sine upon cos basically equals to tan alpha, which is equals to minus 1. Alright. Before proceeding further, make sure that your calculators are in radian mode. That is very important. So now we have the negative value of 10. So negative value of 10 indicates that theta lies either in the second quadrant or in the fourth quadrant because 10 is negative. Now we need to find out the value of alpha here. So that will be equals to base angle, right? So alpha is already occupied, so I will consider the base angle with beta. So beta is equals to tan inverse of 1. Now the value of beta or your base angle is pi over 4 radian. Alright. So we know that we need to travel in second or fourth quadrant, but the range of the question is not same. It says in the question that it's from minus pi and then till positive pi. That means we need to travel in the clockwise direction because we have a negative sign on the angle, right? So if we consider about the positive side first for the counterclockwise, so either we need to go in the second quadrant, right? That is the second quadrant and it is for your positive range, right? So the theta we have in the second quadrant is this one. That is your theta that we are looking for, and the base angle, the beta we had find out in this question, it's pi over 4. So in terms of pi, 180 degree is basically pi, right? So it will be pi minus pi over 4. When you take LCM, you will get 3 pi over 4. So that is your first value of beta, right? First value of your angle when we have in the positive direction, right? For the negative direction in the fourth quadrant, again the value of your base angle beta is same, that is pi over 4. But now we need to move in the fourth quadrant in a clockwise direction. So that means now we are moving in the negative pi by 4. Alright, so now the value of your theta is equals to minus pi over 4 only. Alright, so the final values of your angle alpha, the first value we had find out, it's 3 pi over 4 for the positive side and then minus pi over 4 for the negative side, and that is your answer. Part B, it says that show that cos theta divided by 1 minus sin theta plus 1 minus sin theta divided by cos theta equals to 2 sec theta. So first thing, I'm going to take LCM here. So LCM is 1 minus sin theta into cos theta. So in the numerator it will be cos square theta plus 1 minus sin theta times 2, and or you can say it's a square, right? Yeah, either you can multiply it with 1 minus sin theta or you can apply the square on it. Now we need to expand the bracket here, so it's cos square theta plus a square minus 2ab plus b square divided by 1 minus sin theta into cos theta. Alright, so we have cos square theta plus sin square theta. These two, when you apply the identity here, so that is equals to 1 plus 1 minus 2 sin theta as it is, and divided by 1 minus sin theta times cos theta, right? So in the numerator you got 2 minus 2 sin theta divided by 1 minus sin theta times cos theta. In the numerator you can take 2 as a common, and inside the bracket it's 1 minus sin theta divided by 1 minus sin theta times cos theta. Right, now we can eliminate. So 1 minus sin theta and 1 minus sin theta cancels. The leftover part we have 2 over cos theta, which is equals to 2 sec theta, and we need to show the same value. Alright, for second part it's cos 3 psi divided by 1 minus 3 psi plus 1 minus 3 psi divided by cos 3 psi equals to 4. If you compare your equation with this one, so that is totally same, right? So in fact, instead of theta, now we need to apply just psi here. So this whole expression, this whole equation should be equals to 2 sec, and the angle is 3 psi here, so I'm applying the same, and it is equals to 4. 2 is multiplying when you shift 2 on the right side, so it will be sec 3 psi equals to 4 upon 2. 2 sec is a reversal of cos, so we can say that cos 3 psi equals to 1 divided by 2. Make sure that your calculators are in degree mode because the interval is in degrees. So now you can find out the alpha here. So alpha is equals to cos inverse of 1 upon 2. So alpha equals to 60 degree. The value of cos is positive, that means theta lies either in the first or in the fourth quadrant. Alright, but the range will be changed because when you have psi only, so the interval is from 0 to 180, but when you have 3 psi, so you need to multiply the lowest and the highest value. So the lowest will be same, but the highest is 180 times 3, and that is equals to 540. So that is your interval. 540 indicates that now we need to revolve second time as well, because when you revolve the first time you cover the angle 360, right? So now you need to travel more than 360. That means we need to go in the second quadrant as well, in the second turn. So when the theta turns first time and we need to go in the first or the fourth quadrant, so theta is equals to, in the first quadrant it's 60, in the fourth quadrant it's 300, right? But for the second turn, theta is equals to 180, not 180, in fact 360. After 360 it will be 360 plus this angle here in the first quadrant only, because we are going either in the first or in the fourth. So for the second turn we are moving in the first quadrant only, so it's 360 plus 60. So the final values for theta we have is 60, 300 and 420. Alright, for our case theta is basically equals to 3 psi, and now we need to apply the value, find out the value of psi here. So to find out the value of psi, we need to divide 3 with all three angles here. So that will be equals to psi equals to 60 upon 3, it's 20, 300 upon 3, it's 100, and 420 divided by 3, it's 140, and that is your answer. It's question number 11. It says that the normal to the curve y equals to ln x square plus 2 divided by 2x minus 3 at the point where x equals to 2 meets the y-axis at point P. Find the coordinates of P. Alright. The important statement in this question is the normal to the curve. Alright. First we need to find out the gradient of this equation. So we have y equals to ln of x square plus 2 divided by 2x minus 3. Alright. So we are going to divide in u into v. So we are going to take u is equals to ln of x square plus 2 and v is equals to 2x minus 3. The derivative of u, it will be 1 divided by x square plus 2, and then the derivative of the function, it's 2x. The derivative of v, it's only 2. So you can simplify it. U derivative equals to 2x divided by x square plus 2. Applying the working formula of u into u upon v derivative. So that is equals to v derivative of u minus u derivative of v divided by v square. Alright. That is the working formula of u over v. So what is v? We have v is 2x minus 3 derivative of u, that is equals to 2x divided by x square plus 2 minus u is what? U is ln of x square plus 2 derivative of v, it's 2 divided by v square. V is 2x minus 3 whole square. We have the value of x and it is equals to 2. So we are going to place the value of x2 here. So that will be equals to 2 2s are 4 minus 3 bracket 2 2s are 4 divided by 4 plus 2 minus ln of 2 square is 4 plus 2 times 2 divided by 2 2s are 4 minus 3 leads to 1 whole square. So now you can solve your numerator. It will be 1 times 4 divided by 4 plus 2, 6 minus ln of 6 times 2 divided by 1. So there is no need to write down the value of 1 here. 4 upon 6, it's 2 divided by 3 minus. Now here ln is only with the value of 6, so you need to find ln 6 and then multiply the value by 2. So you will get 3.58. Alright. So when you subtract 2 divided by 3 minus 3.58, you will get minus 2.92. That is your dy over dx at the value of x equals to 2. Keep in mind that this gradient is for the tangent, not for the normal. Alright. In order to find the gradient of the normal, that will be negative reciprocal. So you can say that it will be equals to 1 divided by 2.92, and when you solve it you will get the value of 0.342. that is the gradient of your normal. Alright. Now we need to find out the equation of this normal here. So we have the working formula of y minus y1 equals to m x minus x1. The coordinates of x1 and y1 we can easily find out. When x is equals to 2, we need to find out the value of y. So y is equals to, I am placing the value of x in this equation. So y equals to ln of 2 square is 4 plus 2, 6 divided by 2 2s are 4 minus 3 leads to 1. So y equals to ln 6, right? And the numeric value for ln 6 equals to 1.8. Now I'm going to place the value here. So that will be equals to y minus y1 is 1.8 equals to gradient is 0.342, x minus the value of x1 is 2. We need to simplify the equation here. So that is your equation of normal here. Alright, that is your equation of normal. After that, it says the point P cuts the y-axis. By cutting the y-axis, it means that its x value, it's 0. Alright. So the coordinates for point is 0 comma y. We need to find out the value of y. What I'm going to do, I'm going to place the value of x here, that is 0. So the leftover part, that means y equals to, this whole value will be 0 because x is 0, and the leftover part we have it's 1.116. So the coordinates of P we have it 0 comma 1.116, and that is your final answer.